Hello students, welcome to lesson number 3 on trigonometry. I hope you are all doing well. Good. Now before we begin our lesson, let's take note of the following announcement. Now after going through the lesson, if you realize that certain concepts were not clear to you, don't hesitate to give me a call, okay? So my number is on the flyer on your screen. That is 0245 507367. So don't hesitate to give me a call for further clarification and explanation on some concepts that you didn't get. Okay? Also, I run online courses for core math, elective math, chemistry, and then also for matured entrance examination mathematics. So if you are in need of these services, or if you know anyone who is in need of these services, don't hesitate to give my number to the person or call me for registration and enrollment. Okay? Right. So that is my number. Don't hesitate to give me a call. Okay, so now let's move on to our lesson. Good. The last time we met, we looked at Pythagoras theorem, and then we solved some examples. So I put forward 3 questions. I solved the first one, and I gave you the last 2 to be done as an assignment. So I hope you've all done it. Okay, so let's begin our lesson by going through the assignment, and then we'll see what's next. Okay, so let's begin our lesson. So the question was, find the value of m in the following diagram. So we'll move on to diagram 2, that is the B. So we have our right-angled triangle here, and we learned that this side is the hypotenuse. This side will be the opposite because of this reference angle, and then this side will be the adjacent. So we learned from Pythagoras theorem that the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. Okay, so applying the Pythagoras theorem on diagram B, you should be able to simplify and find the value of m. Okay, so we can get m by squaring the hypotenuse and equating it to the square of the opposite plus the square of the adjacent. We simplify and then we'll get our answer. Right, so let's look at the presentation for the solution. Okay, so the question number is B, so always write the question number before you start. Good. So as I said, our hypotenuse is QS, okay, and then our opposite is RS, and then our adjacent is QR. So that is what we are going to use before we substitute, right? Good. So we'll have QS squared, okay, is equal to RS squared plus QR squared. So this is the Pythagoras theorem specific to our diagram. So now QS was given as 13. So 13 squared is equal to RS was given as 5, so 5 squared. Then QR was given as m plus 7. Okay, so m plus 7 all squared. So you have to put the m plus 7 in brackets, then you square it. So now we have to simplify. So 13 squared is what? 169. and then 5 squared is what? 25 plus, now this is where you have to take notes, m plus 7 squared. Now this is a perfect square, okay? So from algebraic expression, expanding of what? Perfect squares, okay? So you have to go over that one if you've forgotten, expanding of perfect squares. So either you use expanding of perfect squares, or you can also use binomial multiplication, okay? Because m plus 7 is the same as m plus 7 times m plus 7. So you use binomial multiplication to expand, and then you simplify. Good. So I will use the expansion of perfect squares, okay? So where you have a plus b all squared, giving you what? A squared plus 2ab plus b squared. So I'm going to use this form of expansion to do this one. So go and revise if you've forgotten. It's very fast than doing multiplication by binomial, okay? Good. So this one will give us m squared plus 14m plus what? 49, because 7 squared is 49, okay? So now we have 169 equals, so this one plus the 49 will give us what? 74. So we are going to have m squared plus 14m plus 74, okay? So now you realize that the equation we have here is in the form of quadratic equation, okay? It's in the form of quadratic equation because the highest degree of m is 2, and then we have the m term here, and this is our constant. So when we send the 169 to this side, okay, we'll get our equation as m squared plus 14m. Then when we do the subtraction, then we equate it to 0. So we are going to have, we'll send the 169 to this side, so it will give us m squared plus 14m, and because the 169 is positive here, when it comes to this side it will become negative. So we are going to have negative 169 plus 74, okay? And that will give us negative 95. So minus 95 equals 0. Okay. So now we have our quadratic equation. So we'll solve this one using the method of factorization. So where you multiply the coefficient of m with the constant, then you look for the factors of the product of the coefficient and the constant. That's when you add, you get 14, and then when you multiply, you get the product that you had. So looking at our own, the factors will be negative 5 and then 19. So when you divide 95 by 5, you get negative. When you divide 95 by 5, you get 19, but you should look for those factors that when you add, you get 14, but when you multiply, you get what? The product. So we have negative 95. So when we divide the negative 95 by 5, okay, we'll get 19, negative 19. But when you use negative 19 and 5, when you add them, you get negative 14, but we want positive 14. So it means that the 5 rather should be negated and the 19 should be what? Positive. So we are going to have m squared, okay, minus 5m plus 19m minus 95 equals 0. Let me clean this one. I hope you are following. Good. So now, let's see. So we have this. So you group them into two, then you factorize it. Okay, so you come out with the factors. Okay. So the common factor here is m. So m out. Okay, then you have m minus what? 5. Then this one to 19 out. M minus 5 equals 0. So having m out, m minus 5, and then plus 19 out, m minus 5 equals 0. Looking at this, the common factor here is m minus 5. So m minus 5 out, you have m plus 19, okay, equals 0. So now m minus 5 is equal to 0, or m plus 19 is equal to 0. So from this we have m is equal to 5, and then m is equal to negative 19. Good. So mind you, we are dealing with distance, okay, and we don't have negative distance. So it means that our m should not be negative, okay. So we have to state that condition, that our m should not be negative. So we write, but m is greater than 0. So when m is greater than 0, m cannot be negative. So it means that our answer is what? M equals 5. Okay, m equals 5. So this is the answer for the B. This is the answer for the B. So we realize that we use the concept of expansion of what? Perfect squares, and then also quadratic equation. Quadratic equation. So if you have forgotten these two concepts, you have to revise. Okay, right. So let's look at the third one. Yeah, good. So the third question also, it follows the same pattern, but this case everything is in terms of m. So let's look at it. So we have our hypotenuse, we have our opposite, and then we have our adjacent. Okay, so now from the same concept, the hypotenuse squared is equal to the opposite squared plus the what? The adjacent squared. You put down the equation, you simplify, and then you get your answer. So let's look at the presentation. So remember, our hypotenuse is PQ, our opposite is what? PR, and then our adjacent is what? QR. Good. So let's look at the solution. Right. So with that one also, so C. Okay. So we have our PQ squared equal to QR squared, okay, plus PR squared. So this is our Pythagoras theorem. So substituting, we have m plus 3. Yeah. M plus 3 squared equals, the QR also was m plus 2. Plus m plus 1 squared. Okay, so we have this one. So this one, through it all, is expansion of what? Perfect squares that we are going to use. So with this one, you're going to have m squared plus 6m plus 9, okay, equals m squared plus 4m plus 4, then plus m squared plus 2m plus 1. Okay, so this is what you are going to get. So using the expansion of perfect squares, this, you square the first one, you multiply the two terms inside, then you multiply the answer by 2, then you square the third one. That is as simple as that. So you square the first term, you multiply the first term by the second term, the answer that you get, you multiply it by 2. So this time this will give us 2m times 2 will give us 4m. Then you square the third term, you get 4. The same thing applies to this one. Okay, so now we have to group like terms and simplify. So we have m squared here, m squared here. When we put them together, we are going to get 2m squared. We have 4m and then 2m. So when we put it together, we are going to get 6m. Then 4 plus 1 will give us what? 5. Okay. Then here we'll maintain whatever is here. Good. So now we have to group like terms. Okay. So we'll send the m squared to this side. We'll send the 6m to this side. And then we'll send the 5 to this side. So we are going to have 9 minus 5 because the 5 is positive. Okay, then plus 6m minus 6m. Okay, and it should be equal to 2m squared minus m squared. Okay, so 6m minus 6m will be what? 0. 9 minus 5 will be what? 4. So we are going to have 4 plus 0 equals, this one will give us what? M squared. Okay, so 4 plus 0 equals m squared. So it means that we are going to have 4 equals m squared. Okay, so, but it's better to write the variable first. So m squared equals what? 4. So now we have to find square root of both sides. So our m will be equal to plus or minus square root of what? 4. So we are going to have plus or minus 2. Okay. So the plus or minus is there because a negative number squared will also give us a positive number. Okay. So you don't just ignore the negative number and use the positive. Alright, so here you have to write, so we are getting m equals 2 or negative what? 2. But we are dealing with distance. We don't have negative distance. Okay, so it means that we will ignore the negative 2 and choose the positive one. Okay, so we have to state that condition. So m is what? Greater than 0. So if m is greater than 0, m will be equal to what? 2. Okay, m will be equal to 2. So but alright, so students, this is the answer to the third one. Okay, so remember this one too, we used expansion of what? Perfect squares, but we didn't use quadratic what? Equation. So take note of this one. So quadratic equation and then expansion of what? Perfect squares. Revise on those two concepts if you have forgotten. Okay, right, good. So we'll end here. Okay, and then I will leave you with some assignment. That will be example 2. So you work those examples for me as an assignment. The next time we meet, we'll look at it and then we'll move on. Okay, we'll be looking at Pythagorean triplets, or some books or people also say Pythagorean triples. So Pythagorean triples or Pythagorean triplets, that will be our next lesson, our next topic after the assignment that you'll be doing for me. Okay, so let's look at the assignment. So this is the assignment, example 2, but I use it as an assignment. It's a very nice question. You just have to think small and then you are good to go. Alright, so till we meet again, revise, read ahead, stay safe, and don't hesitate to give me a call if you didn't get a concept, okay, and I'll explain it further for you. So the number I on the flyer, make sure you write it down. You can call me anytime for explanation. Alright, so till we meet again, bye.